Hello students, let's solve the next numerical now. The question is, calculate the minimum number of lines on a grating required to resolve the spectral lines of wavelength 5770 and 5790 angstroms in the second order spectrum. Let's take the data first. What is given? Calculate the minimum number of lines. What are we supposed to find out? Number of lines that are there in the grating, right? Capital N. Required to resolve the spectral lines of wavelength. One of the wavelengths is 5770 angstroms, which is 5770 into 10 to the minus 10. Another wavelength is 5790 angstrom, 5790 angstrom, which is 5790 into 10 to the power of minus 10 meters. Then it is given second order, that is n is equal to 2. The formula goes like this. Number of lines in the grating is equal to 1 by n, which is order, lambda divided by d lambda. This lambda here is the mean wavelength, that is lambda 1 plus lambda 2 divided by 2, okay? And this d lambda is the difference between the two wavelengths, that is lambda 2 minus lambda 1. Let's do that first. Lambda is lambda 1 plus lambda 2 divided by 2, which becomes 5770 plus 5790. I am taking 10 to the power of minus 10 as common, divided by 2. So lambda will be 5780 into 10 to the minus 10, as well as d lambda, which is lambda 2 minus lambda 1, right? So 5790 minus 5770 into 10 to the minus 10 is common between both. So d lambda is 20 into 10 to the minus 10 meters. Okay, let's write all these things. However, let me give you a tip, that is, in some books, this lambda over here, instead of them taking it as the average between the two lambdas, they have taken it as the first lambda. Alright, especially in your smart physics textbook, they have taken, instead of mean wavelength, they have taken the first wavelength. However, in the next question itself, in the same book, they have taken average lambda value. Okay, whereas for this particular question, they have taken lambda as 5770, whereas we are taking it as 5780. Alright, let's plug in the values. N equals 1 divided by 2 multiplied by 5780 into 10 to the minus 10 divided by d lambda is 20 into 10 to the minus 10. So n becomes 144.5. Now what is n? It is the number of lines, right, in the grating. So 0.5 doesn't make any sense, right? How can you have fraction of a line? You can't have it, right? So let's fix that as 145. So the number of lines which are required on the grating is 145 lines. So that's your right answer.